Hello everyone, this is Shram from Learnacon with another video on the Internet of Things. For any serious IoT project, you need a message hub that is secure, reliable, and scalable. Many developers start with a standard MQTT broker, but when they try to scale to millions of devices, they hit a wall. That's where a platform like Microsoft Azure IoT Hub comes in. Azure IoT Hub is a specialized IoT gateway with built-in features, supporting multiple protocols, including MQTT. But there is a catch. Azure IoT Hub's MQTT service isn't your typical MQTT broker. Understanding these differences is key to designing and implementation of the right IoT solution. In this video, we will compare these two models. Let's get started. The key differences between Azure IoT Hub and a standard MQTT broker stem from their design philosophies. Azure IoT Hub is a specialized IoT platform built on top of MQTT, tailored for secure, scalable, and cloud-integrated device communication. In contrast, traditional MQTT brokers are general-purpose messaging platform, lightweight, flexible, and ideal for local or small-scale deployments. Because IoT Hub is deeply integrated with Azure ecosystem, it imposes certain architectural and protocol constraints that differ from a fully compliant MQTT broker. In this video, we will explore four major differences: architectural restrictions, authentication methods, lack of broker-to-broker communication, and how each platform handles integration and scalability. Now let's dive into each one. Azure IoT Hub and traditional MQTT brokers differ significantly in architecture and intended use. A standard MQTT broker is designed for general-purpose messaging, offering full protocol compliance, flexible topic structures, wildcard subscriptions, retained messages, and all three quality of service levels, including QoS2 for exactly once delivery. In contrast, Azure IoT Hub is a cloud-native service built specifically for IoT scenarios. It uses MQTT under the hood, but restricts topic formats to enforce device identity and management. These restrictions mean you cannot use wildcard topics or retain messages, and quality of service level 2 isn't supported. These limitations are intentional. They help Azure IoT Hub to maintain scalability, security, and a tight integration with the broader Azure ecosystem. Authentication is one of the most critical differences between Azure IoT Hub and traditional MQTT brokers. Azure IoT Hub prioritizes security by requiring each device to authenticate using either a shared access signature called SAS token or an X.509 certificate. This ensures that every device has a unique identity and secure credentials. Unlike traditional MQTT brokers, Azure IoT Hub doesn't allow anonymous connections or simple username password authentication. In contrast, most standard brokers use basic authentication methods that aren't inherently tied to individual device identities, which can be sufficient for a small scale or internal deployments but pose risks at a scale. This per-device identity model in IoT Hub is essential for managing millions of devices securely and efficiently. Traditional MQTT brokers often support broker-to-broker communication or bridging, which allows multiple brokers to share messages and expand the network. This is useful for distributed systems or local clusters. Azure IoT Hub, however, is fundamentally different. It is designed as a central endpoint for device-to-cloud and cloud-to-device communication. It doesn't support generic pop-up patterns like one device subscribing to another device's topic, nor does it allow brokers interconnection. All communication is routed through the IoT Hub which then integrates with Azure services for processing, storage, or analytics. This architecture enhances security and scalability, but limits flexibility compared to traditional brokers. Azure IoT Hub stands out for its deep integration with the Azure cloud ecosystem. It connects seamlessly with services like Stream Analytics, Azure Functions, and storage, enabling powerful data processing, automation, and long-term storage, all without additional setup. As a managed service, IoT Hub also offers automatic elastic scalability, capable of handling millions of device connections without requiring you to manage servers or infrastructure. On the other hand, traditional MQTT brokers are standalone and lightweight, making them suitable for local or small-scale deployments. However, they only provide the PubSub messaging layer. Any additional functionality, like analytics, storage, or scaling, must be built and maintained by the developer. These differences highlight the importance of choosing the right solution based on your project's scale, complexity, and cloud integration needs. Alright, that's it for today. I hope you've learned something new and valuable. If you enjoyed this video, don't forget to like, share, and subscribe to the channel for more contents on the Internet of Things and cloud technologies. Thanks for watching, and I'll see you in the next one.